But Ken is the global project manager for Teledyne gas measurement instruments, portable gas detection products, and responsible for product line performance, business growth strategy, product roadmap, and the commercial launch of new products. Ken has extensive knowledge and the experience of gas detection and processes for global gas utilities. He joined GMI in 1991, spending 15 years in GMI's engineering department, designing and developing many software and hardware products. Therefore, Ken has led GMI's technical applications development before progressing to portable product management in 2016. Since 2020, Ken has been guiding the Teledyne, now the owner of GMI's research and development of portable products for rapidly emerging hydrogen economy. And with that, we welcome Ken.
Thank you, Paul. Lovely, thank you. Good morning, everyone. Just want to extend a comment made earlier about last night, a thoroughly enjoyable, entertaining night. I'd also like to thank Vivian and her team for putting together such a fantastic program. It's organised very well, so wherever she is, thank you very much. So, yeah, from the accent, I'm from Scotland. There seems to be a lot of Brits arriving in the UK just now. Previous speaker, it's about like the 1600s with all arriving. But what I would like to do is talk about GMI, a relationship with Heath. So as Paul mentioned, I am responsible for product. We also have Patricia Kittelberger in the room. I think she's actually just walking around just now. If you don't know Patricia, I'm quite sure you'll get to know her very soon. So who are we? Well, GMI, so as Paul mentioned, GMI were acquired by Teledyne 4 years ago. I keep referring to it as GMI. I get a corporate row every time I don't mention Teledyne GMI, so apologies. But we were created in 1947. We're actually celebrating belatedly our 75th anniversary this year. It was meant to have happened a couple of years ago, but with COVID and a few other issues, never quite happened. But we are 75 years plus. Our specialism is in designing portable gas detection products, primarily for gas utilities, but also in the industrial safety market. We are based in the UK. We're based in Scotland, right next to Glasgow Airport. And we've got a long history in partnership with Heath. Heath are our exclusive distributors in the USA for our portable products. And as Paul mentioned, we do have a long-standing partnership going back 25 years. In fact, probably Paul's the only one in the room that remembers some of the reasons of our success in the US going back 25 years. And it's interesting to note that when we first came to the US, we had a gas detection product, but the real thing that set us apart was a software application. We were the first globally to have developed a software package, a very simple package, and all it did was it maintained the fleet status, the calibration fleet status. It was written in DOS. Does anyone remember DOS? A few heads. So it was written in DOS, but that was the tool, that was the breakthrough that gave us the strength to move through America. And I think from yesterday and today, what we're recognizing, and it's been mentioned all the time, it was Andy Treadway yesterday said that from Atmos, the importance of digital data capture. Paul mentioned it yesterday as well, data-driven organization. You're hearing it all the time. The future is in the data. So before I go on to the kind of couple of products, a bit of background on some of our current products. We have the Gasurveyor 700. It's our latest product. It's been out in the market for a few years now. It's a platform product, very expandable. It's used for all the different functions and features of typical gas utility applications. What we've just added to it is the hydrogen capability, and I'll talk about that in a bit more detail shortly. But it's a platform product. We can add sensors, we can add technology, and it's a very, very robust product. The second one, just to draw your attention, another PHMSA compliant product is the Gasurveyor 500, a very, very multi-purpose, very, very durable product. Again, it does all the typical applications, and I think some of you here may recognise some of these products. Very, very durable, very long-lasting, and certainly lasting extensive use in the field. Again, very configurable, AV alarms, just what you'd expect from a gas detector for your applications. We also have the GT series, a paddle style, and the beauty of this product is that the sensor is right in the tip, so it's absolutely instantaneous gas detection. Very, very, very fast response. All of these products are super configurable. Someone mentioned, I think it was from Con Ed, can we switch off the level of detection? Absolutely, fully configurable. We can program these devices to not switch on if calibration is overdue. They can be programmed to not switch on if a bump's overdue or not. So it's fully configurable, and I think we recognise the benefits of that. We also do personal monitors. Typically, if you're in a confined space, you will want your operatives to be protected. So we also do these devices here. We sell these mainly into the industrial space, but we do have lots of gas utilities globally that buy these to give additional protection to the users. Single gas monitors, typically oxygen, carbon monoxide, or even H2S protection. And then the PS200, the black device, that's a standard 4-gas monitor with an internal pump. So if you're doing confined space work, you obviously want to sample the strata before you enter the confined space. This device does that for you. It draws the sample, gives you the reading. And we're making a very interesting development with this product right now with the cloud. And I'll talk about that shortly as well. So the cloud, we recognised several years ago of the importance of getting the data out of the field and into your hands for analytical purposes. Data is absolutely critical, but you have to be able to work with it and use it. There's a whole host of data out there, but if it's not processed properly or used properly, then it's meaningless. And I would say up until a few years ago, a lot of data in the field was being lost. Your teams would do things, they would encounter situations, alarms, dangerous situations, they would deal with it, go home, forgotten. Now, in the last few years, all this data is now being captured. Our instruments capture everything from switch on to switch off. We call that a session, and we want to capture everything so that when it's uploaded to the cloud, we can look at it, analyse it, and make informed decisions. We have this strapline at Teledyne GMI, field data, or field data is business data. It's absolutely true. We've done projects in the UK with gas utilities where they have used the data from multiple sessions and they've changed their operating processes based on that data. That was data that was previously lost and not used. We're now capturing everything from switch on to switch off. So you think what that means. That's mode changes, alarms, anything that happens is now captured. And how do we visualize that data? Well, we have the cloud. GMI, a few years ago, we had our own cloud solution. But when we were acquired by Teledyne politely told us to abandon ours and move to theirs. So we agreed, obviously. So the cloud, as you imagine, is taking our instruments. It's taking you can see there in the image, it's got the it's got the GS700, it's got the GS500 and the personal monitor. All this data has been sucked out and pushed into the cloud. At the beginning, I mentioned that one of our initial successes in the US was this very simple fleet management tool that we developed in DOS. This is pretty much the evolution of it. We're still doing the same things. We're now capturing bump and calibration data. We're capturing all the session data, plus we're also providing the full fleet management, all in this cloud solution. I know some of you here, I won't identify you, are currently using it, but it's a very, very powerful tool for many reasons, not least compliance. We also obviously do a whole range of accessories and probes. So by all means, if you're looking for more information, Heath being our unique distributor in the US, either contact them, or if you wish, you can also contact the details from the QR code. So hydrogen, Paul mentioned that he thinks that the UK or Europe is perhaps several years ahead or a few years ahead. I think what's probably happened, we were contacted by a European utility back in 2021 and asked to partner with them to develop an instrument. So we did that. So we've been developing this instrument for 3-4 years, and happy to announce that this instrument, which is fully intrinsically safe certified, was released in Q3 of last year. So this product is available. It's being used globally, but I would have to say it took some time getting there. And the reason it took some time getting there is we designed a product, but there was limited places where we could test it, but there wasn't hydrogen pipelines, there wasn't hydrogen infrastructure. So we had to box very clever and work with other utilities, other organisations to access all the field trials that we were to be involved in. So as I mentioned, we were working with SGN in the H100 project, and their ask to us was one instrument that would measure from 0 ppm all the way up to 100% volume for natural gas, for hydrogen, and hydrogen blends. So that was the ask, and that's what we released last year. We have worked with various utilities to have these evaluated. We've also worked with UK government-funded organisations. Ultimately, the field trials were conducted successfully, and the product was released. One of the main things that the instrument does, throughout the 2 or 3 years of the trials, we were trying to work out what the best user interface was. How do we present the data to the users? Initially, we put a lot of data on the screen, just because we weren't sure what we wanted to ultimately use. But what we homed in on is what you see on the screen now. If you're looking for a leak, if you're out on a hydrogen investigation, ultimately, your person who's looking for the leak is looking for the flammable concentration of the mix. So we display the total flammability reading of the mix. If it's natural gas and hydrogen, we work out what the total flammable reading is, the total LEL reading or volume reading. However, we also allow the user to pick out which parts, if they want to look at the natural gas part only, they can do that. Or if they want to pick out the hydrogen part, they can also do that. So it's allowing the user to pick out any part of the blend. And the reason that this was important in the UK was because the initial trial, the initial customer or the initial utility, they were putting 100% hydrogen into a pipe running in parallel next to a natural gas pipe for part of the trial. So they wanted to make sure that every eventuality was covered. So this instrument, the Gasurveyor 700, does everything for hydrogen. It does, as I mentioned, it does the blends, it does 100% hydrogen or natural gas, all in one instrument. Worth pointing out as well, and it's maybe premature, but being part of Teledyne, Teledyne also have other hydrogen projects or business units. So they also have fixed systems that can do things. They can also do hydrogen flame detection. So whilst we're part of Teledyne, we're doing the portable part. There are other options and solutions for hydrogen. The hydrogen economy is huge. There's no doubt about it. And lots of countries are pushing ahead. Probably one thing I would say, just as an observation, is that it seems like different parts of the world all repeat the same evaluations at different times. And it would be perhaps better if some of the learnings and understandings from Europe could be used across the world to move faster. So just to summarise for this instrument, yes, it was released last year. It is intrinsically safe. What we do have, however, is the intrinsic safety is IEC EX or ATEX. So that's a European type certification. However, having spoke to many of you in here and other utilities in the Americas, the ATEX certification is acceptable just now. Yes, of course, we'll work on UL, CSA, but having the intrinsic safety certification ticks the boxes just now to allow certain trials to commence. So there were some limitations in the phase 1 release. The phase 1 release pretty much gave people a certified instrument to make the measurements. What it didn't do, it didn't give the automatic calibration. It didn't give the cloud compatibility. And there's also some issues with other sensors. When you're measuring hydrogen, there are cross-compensation issues with carbon monoxide sensors. There's also response issues with oxygen sensors. So ongoing developments with those, but the instrument that was released last year, those 3 bullet points weren't covered. So this year, 2024, we have 2 subsequent releases, phase 2A and phase 2B. Phase 2A will address the first couple of issues. So we do now have our calibration equipment working with hydrogen, and we also have the cloud connectivity. So the cloud connectivity, as you'll see shortly, that might be of particular interest in trials, field evaluations, when you want to map what's happening, readings with hydrogen, and we can push that data to the cloud and visualize what's happening. And then phase 2B is the second half of the year. That will add the North American certification. That will add CSA and UL. I think it was mentioned by the last speakers that the issues with certification are not trivial. Anyone working or engaging with UL, CSA, it can be tough at times. Just pulling all that together, so we now have all these instruments with all this valuable data. How do we quickly and easily and securely get that data from the field so you can visualize it on your smart device? Well, this image here, and it's certainly not rocket science, but it makes the process very, very easy for getting the data out and into your hands. So as you can see, we have the instruments, we have our docking station, we have our router, and then we have the cloud. So it's a very seamless, straightforward process of pushing the data all the way through into the cloud. The Teledyne cloud is AWS, very secure. We actually had delays launching the cloud because of the Teledyne. They've got a team. Whenever anyone releases a cloud product, they do a thorough deep dive on its resilience, and we had to make sure that complied. So you can see what we're doing here. Everything inside the instrument, all the session data, plus all the calibration data. Once you push that up to the cloud, you've got everything at your fingertips. You've got all the compliance records of your calibration. You can type in a serial number and instantly see that calibration was current. You can instantly see all the jobs that the person attended. You can see all the data. You've also got the calibration data from the calibration station, and then that gives you the fleet management, where you can create reports of how many instruments are due calibration, how many, more importantly, are overdue calibration, any instruments out in the field that are requiring calibration. So there's a lot of good facilities and tools there that you can use. Just a couple of screenshots on what it looks like when you push that data now to the cloud. What you can see on the screen is the bumping calibration. Very, very simple dashboard. I think again, yesterday's conversations or yesterday's meetings talked about simple user interface. Very, very simple. It has to be. It really has to be. How many people have picked up their new iPhone and the first thing they've done, they've gone to download the user handbook? Nobody. Nobody does that anymore. Everybody expects the user interface to be nice, simple, and easily usable, intuitive. And we have to make sure that continues to happen. What we have here on the screen is exactly that. We have a very, very simple interface. Thanks, Vivian. Very simple interface showing all the calibration data. You select the instrument of interest, and you can see the results. Very straightforward. This for me is the pivotal part, is the session data. Again, every single thing that happens to that instrument from switch on to switch off is captured. Every single aspect, and we can upload all that data and start digging into the session data to find out what happened. So as a simple example, what we can see on the screen is I've selected this session, and it turns out the user did all this. They entered different modes of the instrument. I can now select one or more of these just to find out the specifics of.
Hello.
Hi.
A question. The data, is possible to obtain the data to translate or transport to our GIS Esri? Is compatible, or we need only to live in your cloud?
There's an option to overlay your infrastructure data on top of this. So you can overlay your infrastructure data, so you can now visualize the gas reading next to pipework. So we can import that on top of this.
Okay, is AWS is correct?
Yes, yes.
Okay, thank you.
So the data you see here is very simple, very clear. You can see the individual readings. We have the bar hole readings. We have the pipeline gas discrimination readings. We have a nice simple map of where these readings were taken. All very simple and straightforward to get the data to the cloud and to access. You can also see the graphs, so we can toggle between the actual graph or the actual map. Very, very simple, very straightforward. A bit difficult to see the data here, but you're getting a flavour of what this does. It pulls the data out very simple and very easily. So again, it's pulling all the data from disparate instruments, personal monitors, or Gasurveyor 500s or Gasurveyor 700s, all into one central location. The fleet management, again, a very powerful tool. You can keep track of all your instruments, where they are, who has them, who's in charge of them. There might be a manager in charge of 10 or 15 instruments. We can now create this on the cloud where the whole fleet of your instruments are now captured here, where they are, who has them, and that type of thing. If you're further interested, either speak to anyone, your salesperson from Heath, and we can organise a demo. We've done several already online, very, very quick, very straightforward. Like lots of these things, actually seeing it in operation is better. It's a very, very simple demo that shows you the strength of what we have.
Regarding the hydrogen GS700, will you have the ability to configure the GDU to support the hydrogen unit along with the legacy units?
Yes, we do. The reason we didn't release it prior to this year was we're still doing tests to make sure if we fit hydrogen to the back of the GDU net, there's no issues with leaks. So if you have a legacy Gasurveyor, if you have a legacy GDU net, you can now connect hydrogen to that unit, yes.
Hello, Ken.
Who's this?
This is him. With the GS700 hydrogen unit, when you are doing the calibration, typically we're looking to utilize a blended ratio from 5 to 20%. For the calibration, is the test gas 100% hydrogen, or are you calibrating with your blended ratio that you intend to run as a LDC?
So we have up to 3 spare ports for connecting gas. So if it depends on your application, so we can connect either 1, 5, 20% or 100% volume hydrogen. So it really depends on what your application is. I think probably for accuracy across the whole range, we might have to add 100% hydrogen. I'd need to verify that, but we've got options depending on applications.
Okay. Thank you so much.
Okay.
Using the legacy units, since some of those are equipped, legacy GS700 units are equipped with CO sensors, attaching it to the GDU, will that have any negative impact on those sensors?
Yes, it will. If you have 100% hydrogen connected to your GDU net, and that is then feeding into these instruments with CO sensor, that CO sensor will be damaged, yes.
So having a standalone GDU would be ideal for your...
Yeah, perhaps.
Thank you.
The lower concentrations of hydrogen don't damage the CO sensor as much, but if you're connecting 100%, then yes.
Just going on with the blending, with the UK government now approving blending up to 20% in the gas distribution network, what's the accuracy on different concentrations? Because we know it's going to be vary significantly from like 1% or even less right up to the 20%. So what's the accuracy in the range if we're only going to be testing or calibrating at a 5, 15 and 20% level?
Yeah, so as you may know, we worked very closely with SGN during this project, and their project actually kicked off with 100% hydrogen only. And it was only towards the last year that they had to pivot towards hydrogen. So they needed blended hydrogen. So their ask was that they have to be accurate to within plus or minus 10%, all the way up through all the blends to 20, and then all the way up to 100%. So that's what we met. Thank you.
Okay.